Hi folks, welcome back to 6.3 where we're working on shell method, but also decision making between when we should use washer and when we should use shell. So let's take a look at question number 4. It says find the volume of the solid of revolution generated by rotating the area between the graph of f of x equals square root of x and g of x equals 1 over x over the interval from 1 to 4. So let's sketch a diagram. I'm going to do f of x in an orange and a g of x in a blue. All right. So f of x is the square root of x. That is a curve that we should know and recognize. And I'm going to start at 1 and I'm going to end at 4 because I know that's the only part I need. Okay? So square root of 1 is 1. The square root of 4 is 2. And so I've got 2 points that help me define my square root of x function. Let's do the same thing for 1 over x. So 1 over 1 is 1, and 1 over 4 is 1/4. And so this bottom part defines that curve 1 over x. Now I'm going to seal the region off at x equals 4 because that's what my bounds told me to do. All right, so now I've got this shape, and I'm going to go ahead and think about what it looks like when I revolve it around the y-axis. So my axis of revolution is right here. Okay. I'm going to go ahead and draw the reflection part in red, and let's see what we get. All right, so I have two choices. I can use washer method or I can use shell method. So let's see what happens if we do washer. If we choose to use washer, then we need lines that are perpendicular to the axis of revolution. That means we would have to draw lines like this. Now, shell method would require us to have lines that are parallel to the axis of revolution. Oops. Sorry, let's go back and erase that green line. That was not perpendicular. We want one that's perpendicular to the axis of revolution, so that might be like this one. Okay, or this one. And then the parallel to the axis of revolution might be one like this, or one like this. Now I'm drawing more than one line because I really want to scan and see like what's going to be less work for me and what is ultimately going to be the most efficient way to achieve my answer. So when I look at the green lines, they're fine. I have a pink line on the right and I have another curve on the left. But what's leading me away from this washer method is that this green line has a left curve of the orange, whereas this one has a left curve of blue. And that means I'm going to need two different integrals, and I don't really want to do that, so I'm not going to use washer method. In fact, I'm going to erase these green lines and the red parts. All right. So let's see what happens with our shell method, though. Do we have a top and a bottom that are the same for every purple line that we would draw? And the answer is yes, we do. So we are going to go ahead and use shell method. All right, that means we need volume equals 2 pi, the integral from a to b of radius times height dx. Now let's fill in our a and b and our radius and our height. So I know this is going to be 2 pi. I start at 1, I end at 4. My radius is just my last letter in the case when we are rotating around an axis. That means I can fill in an x for my r, and my height is going to be this top curve minus the bottom curve. So this is my top curve, and this is my bottom curve. All right. Now let's go ahead and distribute and simplify so that we can take an integral. 2 pi, the integral from 1 to 4 of x to the 3/2 minus 1 dx equals 2 pi. Integral of x to the 3/2 is 2/5 x to the 5/2 minus the integral of 1 is x. Plug in 4, plug in 1. All right, so 2 pi, I have 2/5 times the square root of 4 to the 5th minus 4 minus 2/5 times the square root of 1 to the 5th minus 1. All right, let's see what this gets us. 2 pi 2/5 times 32 minus 4 minus 2/5 plus 1. Okay, now this condenses to be 2 pi times 62 over 5 minus 3. I'm going to go for a common denominator of 5. That will give me 2 pi times 62 minus 15 over 5, which will give me 47 times 2 pi over 5, which will give me 94 pi over 5. Okay, let me zoom back out so you can see the whole problem. And so that is the method that we chose, shell method, again, because it led to an easier integral. When we come back for the last video in this practice, we're going to take a look at what happens when we revolve this around the x-axis. All right, I'll see you there.